So, welcome to lecture number 17 of environmental geotechniques, and we have been discussing about characterizing the geomaterials with a interest that how to utilize them, how to valorize them, how to create value out of these materials. And this is where I have been discussing about the physical characterization, mineralogical characterization, then we were talking about the granulometry, that is how the grains attribute to the overall performance of geomaterials. And then I also discussed about some advanced techniques which are being utilized these days to understand the microstructure of the geomaterials, because most of the research which is going on in today's world is directly or indirectly related to the microstructure of the material. One good example of microstructure which can be detected by using scanning electron microscopy, which we discussed in the past, would be designing the concrete which is highly durable. For that matter, even if you want to see how the microbially induced calcite precipitation is taking place on the particles, you can do SEM. And those of you who might get a chance to work in the mineralogy and how these minerals are arranged in a matrix can also use scanning electron microscopy to understand the matrix. That matrix influences the entire engineering behavior of the geomaterials. Migration of a fluid through the matrix is a big question which everybody is trying to understand. It could be flux, could be current, it could be a chemical, it could be fluid, it could be flushing of microbes, viral loading and so on. So, it is a combination of everything which we defined earlier as thermo-hydromechanical coupling and so on. So, I am not going much into the details of these type of modeling, because that would be taken up in a slightly more intense course, which is environmental geomechanics, which I teach to the postgraduates under CE 641, and these videos are already available on YouTube. You can check it out. So, let me now introduce another concept, that is the chemical characterization of geomaterials. Now, you must be realizing that chemistry is becoming a very important aspect of today's life. Why? Because when we talk about the environmental pollution, the pollution term itself is directly related with the chemical species. Something which is unwanted in a system is a pollutant. Something which is unwanted. All right. So, you might be creating or synthesizing a mineral, and there happens to be another species of mineral which was not required. This becomes adulteration, this becomes contamination, this becomes unwanted act. Okay. So, all these types of English or the adjectives which I am using can be quantified by studying the chemistry of the geomaterials. My another analogy as far as the chemical characterization is concerned, if you look at today's medicine system, and from this I derive a lot of analogies between what we do as environmental geotechnologists and what the practitioner medicos do is very similar. So, if I consider soil, rocks, geomaterial as a rock mass, soil mass, geomaterial mass, they consider human body as a body mass. And then the common thing is the blood chemistry, the serum chemistry, urine chemistry and so on, excreta chemistry. The same thing, same concept we are going to use when we take help of characterizing the geomaterial based on its chemistry, chemical attributes. So, courtesy modern day electronics, we have wonderful devices which can talk about or which can give you an idea about what is the chemistry of this material. So, the first one in the series is XRF analysis. Remember, previously we talked about XRD. XRD was X-ray diffraction. X-ray diffraction gives you the mineralogical composition. Of course, the mineralogy itself is a chemistry associated with the minerals. So, indirectly you were trying to identify how minerals are a constituent part of the geometrical matrix, because each mineral then has a typical attribute or typical way to interact with the environment. And environment is nothing but sun, rains, groundwater, contamination, bacteria, viral loading, effluent gases, effluents, municipal solid waste, industrial byproducts and so on. Fine. So, this is what is XRF fluorescence. You use fluorescence to understand what is the composition of the geomaterial, chemical composition, oxide level. So, this is a system which is available in IIT Bombay, and IIT Bombay caters to the samples from all over the country and all over the world in fact, and very simple device. I will show you how to make the samples and then how to calibrate this machine. Before you start utilizing it, there is a calibration associated with this, and what it gives you is percentage oxides of the elements. Now, I think you can understand, if you are a businessman and you want to utilize the waste, the first thing you have to do is take a little bit of the material and very quickly expose it to XRF facility. XRF will tell you what are the constituents. Clear? Now, if you have developed a technology so that you can segregate these oxides of the metals, then you can have a process industry. Where is another application? Most of the ports in the country, including the seaports or the airports, you must have seen they are using X-ray machines. Of course, they are not doing XRF because their interest is not to do fluorescence to get the composition of the metal, but indirectly what they are doing is they are detecting whether it is a metal, non-metallic object. Clear? That also is through XRF, but they are not interested in composition. But if they want, they can find out if you are carrying some narcotics, then they can detect what is the composition of which compound in the material which you are carrying. So, these are simple devices which have made life very simple for the practitioners of our subject. So, the first thing is conduct XRF to understand what is the composition of the material. The second thing you have been talking about since long is the leaching. If this substance comes in contact with water and if this interaction happens to be prolonged, what is the impact of this interaction in the long run to the geo-environment? Clear? Number 2 is the age of modern, industrialization. Everywhere a lot of industries are being created. Now, the question is that you are creating an industry, what about the effluents? How these effluents are going to contaminate the geo-environment? And you remember the analogy which I have drawn earlier, that somebody's activity and you are getting influenced at downstream. Clear? So, how are you going to create cases out of it? Most of the industries are facing litigations. Got it? Why? Because nobody takes responsibility. Now, somewhere if you create a facility, disposal facility, and if it is unengineered, non-engineered, what is going to happen? When the rains come, the waste is going to interact with the water and percolates in the ground and becomes a part of the groundwater. Now, incidentally, you have created an industry somewhere and the blame is going to come on you. Why? Because of creation of this industry, the whole area is getting contaminated. I am just creating a hypothetical situation. Now, how will you fight out these cases? How will you put up these cases in a court of justice with the technical evidence? Are you realizing? So, most of these characterization schemes, again I repeat, are becoming a important exercise in what is known as forensic engineering. What is forensic engineering? Most of the forensic examinations are done on the dead bodies to identify the cause. Now, here we are trying to find out the cause of who is the culprit and effect, what is the effect and how much. So, ICP is an interesting technique where you can take some samples of the soil mass, rock mass, groundwater which is supposed to be contaminated or non-contaminated, And then there is a technique. You allow interaction of this material with water for some time, take out the filtrate, and then do ICP-MS analysis. ICP is inductively coupled plasma, MS is mass spectrophotometry or spectroscopy you can say. It gives you what is the percentage of unwanted elements which are present in the system. So, if you try to set up any industry anywhere, the first thing you have to do is take several samples of soils and groundwater and rock and establish that before you intervene at this place, this was the background concentration of all the chemicals. Because tomorrow after your production starts, people are going to challenge you, that is all because of you. Fine. What you have to do is you do the sampling, the rest of the things are done by the guys who are handling these instruments which are very expensive. Everybody is not supposed to handle these samples and they are expert trained operators who operate these machines. Then comes the pH value. Even in fact, the pH of the blood also people are talking about, pH of the urine also people are talking about, correct. So, what is the pH of the effluent which you are discharging? It becomes very important. Then comes the gas chromatography. Okay. What gas chromatography does? ICP is meant mostly for inorganic species. Clear? Now, when you do GCMS, gas chromatography mass spectroscopy, this is for volatile compounds, mostly organic in nature. That is the difference between the two. So, most of the industrial processes where dyeing is taking place, clothes are being colored, leather is being processed, most of the food items are being processed, most of the electronic items are or electronic gadgets are being produced, clear. So, this is where you have a combination of organic inorganic systems. Oil fields where the oil is being taken out, hydrocarbons, these are organic compounds, clear. So, you want to estimate because of extraction of the oil and gas how much the geo environment is getting affected, how much is getting contaminated. Take samples of groundwater, take samples of the soil, process them, do GCMS and you can obtain this. Very expensive tools, but very precise. Long back we were talking about decontamination or remediation of the soils because of spillage. I hope you remember, clear. So, there was an oil tanker, you must be reading in newspapers also. So, there is an oil tanker, mid sea there is a collision, then what is going to happen? There is an oil slick, clear. Now, oil slick is a big business, believe me, because there are not many experts who can handle this. And there was a case few years back, you must be, if you go back to the Times of India news clippings, you will realize that this happened in our own country at one of the locations, clear. So, millions of tons of oil, crude oil or the petroleum, if it gets slicked, how it is going to influence the geo environment is a very big question. Now, how to contain it? Because it has happened mid sea. Read as much as you can and maybe create a startup on this, because this is where you are dealing with the big industries. So, there is a Coastal Protection Act also, there is a special economic zones also, there is a CRZ, coastal, what is it? Coastal regulatory zone, CRZ. So, there are big rules. I think all of you should study this, those of you who are more into the policy issues and those who are in the advocacy of engineering. Engineering today is not only solving equations and the problems, correct. It is much more of how are you going to put up the cases which are being created by people like us based on the facts and figures. Now, how are you going to interpret them in a judiciary environment is a major issue, because that is where the whole fight is. So, I hope you are realizing this chemical characterization is not only just for the sake of fun, it has lot of intricate applications. Then of course, there is nuclear magnetic resonance, you must have heard about when you were studying your 10+2 physics, phase change of the material, clear. So, there is one material which slicks, interacts with another material and there is a phase change. nuclear magnetic resonance can be done to understand how these type of phases are changing. Normally, NMR is done on the laboratory samples to study, let us say, freezing point of water. If I ask you a question, have you really felt at what temperature and pressure the water freezes? Phase change. Show me happening this. This is where NMR can be utilized. Clear? CO2 getting dissoluted in brine solution, CCUS. I want to understand at what pressure temperature this CO2, which was earlier an entity, would become a part of the brine solution. Phase change. Got it? I can do NMR. Gas hydrates he is talking about, Now, gas hydrates is a process where at a given temperature and pressure, the gas which is available in the sediments get trapped and becomes frozen. Phase change. So, these are the applications in the modern day science and technology of these tools, which have been earlier being utilized by chemist, physics guys mostly, and thermodynamics people, all right. FTIR, I think I showed you once some of the graphs where if I want to understand what is the bonding between the contaminants and the geomaterials. Why do I want to do this? Because there is a situation where somebody claims that because of your activity my soil has got contaminated, correct? The best thing is take the samples, do FTIR, see what type of bonds are available between different types of elements, carbon, hydrogen, oxygen, sulfur, clear? And then what is the energy associated with these bonds? Why energy is required? Because you want to do remediation tomorrow, you want to clean it. Since long we have been talking about how to clean the soil, how to remediate it by washing, clear? By heating, by purging hot air, by adding some chemicals and so on. So, I think now you are getting the answer that how to deal with this type of situations. So, simple example is take the samples, keep on washing it, remediating it, and keep on doing FTIR at every stage to show that initially the soil or the geomaterial was so much contaminated. Now, because of my intervention, because of my intellectual thinking, applications, I have decontaminated it and then charge accordingly. Hope you have understood the whole process, correct? Simple techniques, but very important techniques, very powerful techniques. In the recent days, my students have, particularly Dr. Goli, has utilized this equipment FTIR for determining the presence of microplastics. This is something new, because today's is the world of microplastic, nanoplastic. Everybody is talking about this. There are so many clippings, I am sure. You just watch over internet, you will see that everything is contaminated because of nano, microplastics, correct? How will you detect it is a big question. So, one of the techniques is you can use FTIR. And if you want to do very precise determination of nanoplastics, then you should be having attachments where the resolution level goes up to the nanomicrons level. Then cation exchange capacity, which we have been discussing since long, that what is the inherent property of a geomaterial to exchange the basic ions which are associated with it, sodium, potassium. How easily the sodium, potassium can be replaced by calcium, magnesium, iron, arsenic, cesium, chromium, clear, to contaminate it. So, all this English which I have been speaking, if you really want to ask a question that how to quantify all this English language, one simple mathematical term is cation exchange capacity. So, take the soil, do some tests as per the guidelines which are provided by the codes, and then show that for this material the cation exchange capacity is this, for another material is very low or high. So, typically sands will show very low cation exchange capacity, inert passive materials. However, the clays will show you very high cation exchange capacity, And that is the reason most of the clays are utilized for various medicinal purpose, not the sands. Sands are abrasive. So, if you consume them, the chances are that you might damage your esophagus and intestine, because these are sharp crystals of quartz. Clear? The clay minerals are soft. Why soft? You now remember, see whatever the basic course, there is a hygroscopic layer on the clay mineral. Clear? So, there is a coating of moisture on the clay minerals, which makes it just like as juicy as the grapes. Got it? So, they are very soft. I can use them as the best possible carrier of medicines in the pharmaceuticals, creating pharmaceuticals. So, several applications. Clay mineralogy is something which has to be studied by guys who are into several companies where you are manufacturing toiletries, cosmetics, pharmaceuticals and what not. In civil engineering, construction, rheology of the slurries, any other example which comes to your mind? In petroleum engineering, you have the maximum possible utilization of the drilling fluids, is it not? And one of the basic components, I did long back a project for a company, I can't name it, but there we were designing the deep drilling fluids. Very interestingly, what happens is when you go deeper up to few kilometers deep down, you have to plug the wells. Imagine the pressure which is going to be existing there of the fluid, which is nothing but hydrocarbon. So, you require a plug which can sustain pressure, temperature, clear? At the same time, its rheology is very important, because you have to plug it at that depth of few kilometers. So, the segregation should not occur, then this becomes a very interesting design problem. So, hope you are realizing that where the chemistry becomes so much important, and those of you who can take it up should come forward, because each of these sectors which I have talked about requires a lot of people who can help these sectors in the right manner. Now comes a very big and very vast subject known as pore solution sampling. What is the pore solution sampling? In the beginning I gave you an example, it is something like withdrawing the blood sample. So, you must have seen the whole medical diagnosis is based on, you go to the doctor, the first thing is they recommend you few tests, complete hematology and what else they call it, I do not know. I mean, you are supposed to have body chemistry. So, body chemistry is to be done, and then similarly what we will do is we will take out the samples of the soils and the rocks and then try to understand what is the characteristics of their pore fluids. The fluid which is present in the pores is similar to the blood which is present in the human body. So, if you can diagnose human body by few drops of the blood, you can diagnose the level of contamination of the geomaterial by withdrawing the pore solution from it. Now, this is a big subject, and this requires a lot of patience and expertise and the paraphernalia. So, what I will do is I will try to quickly go through the tools which are used to perform all these tests, starting from XRF, ICP-MS, cation exchange capacity, pH you can measure by using a glass calomel electrode, which you have studied in your basic sciences, that is not a very big deal. And NMR is specialized, so because every lab will not be having NMR, but those of you who might end up doing research in multiphase geomechanics, which is the upcoming topic, and where many of us are trying to understand the basics of the multiphysics of the geomaterials, these type of tools have to be in the laboratory. And of course, FTIR, which some people might be having in their laboratories. So, this is a typical XRF palette. These are the discs, and in this disc these are made up of aluminum, approximately 1 inch in diameter and approximately 5 to 7 mm in the thickness. So, what they do is half of the disc is filled up with the cellulose acetate. Cellulose acetate is nothing but a glue, and on the top of that you spread the sample powder form and then pelletize it. Pelletize it means you take another half of the pellet or the aluminum disc, close it and then put it in a UTM, apply pressure. So, because of this pressure, what happens is the cellulose acetate which you have put as a cushion interacts with the powder of the material and forms a monolith system, and that monolith after certain time becomes a pellet. So, what I have shown you here is a pellet. Now, these pellets are fed into the XRF machines and the analysis is done to obtain the chemical composition. I mean, you need not to worry about all these things because this is done by the operators. You will get certain results like this. So, where I have written this calibration of the setup. So, calibration of the setup is done in two ways. One is the physical calibration and one is the chemical calibration. Physical calibration is normally done by the operators, setting up of the beam of the X-ray and then the platform on which the samples are kept, the temperatures and other things which have to be maintained. What you should be doing is the chemical calibration of the machine, because if you do not do it, the chances are that the previous sample which was analyzed on this machine might mislead you, clear, in getting the composition of your sample. So, as a rule, what is done is, if you are dealing with the soils, there are special calibration standards. Okay? They are utilized to calibrate the setup first and then analyze your samples. So, I have shown a table here which indicates what is the elemental composition of the materials, geomaterials. So, here you will see elements are silicon, aluminum, iron, titanium, sulfur, calcium, potassium, magnesium, phosphorus and so on, correct. It depends upon your requirements, what is that you really wish to understand about. On this side I have shown different types of material, CS is the silt, WC is the white clay is nothing but the kaolin, IC is the chalk sample which we got from some other country. Then these are RSS, BSS are the sandstones, because our research is mostly into the sandstones. So, we have been working on sandstone quite a lot. Then fly ashes of different types, sanospheres of different types, and then GGBFS which we have been talking about. You can put silica fume here also, that also can be done. These are the typical geomaterials admixtures which are normally used in our subject day to day life. Now, what is that you can decode from here? Most of this information is computerized these days, you need not to apply your mind. You will get all these compositions listed. Now, depends upon in which profession I am. If I am a guy who is coming from, let us say, cement industry, I want the materials to have more calcium, got it? If I am a civil engineer and my basic intention is to utilize this material as a fill material somewhere in the retaining walls, foundation pads, reclamation of the land, I do not require calcium there, I require more of silica. So, I am sure you must have studied that there are different types of material known as argillaceous, siliceous, carbonaceous and so on. I hope now you are realizing that based on these simple experiments, testing, you can differentiate between the material and you can create a market for it. This is what is known as waste to wealth today. Everything which is lying here and there unutilized, if I study it properly, I can create a business out of it, value out of it. Circular economy also starts from here. How? I do not know whether you have questioned this or not. I am the operator of a landfill or a disposal unit, clear? and then somebody sends a truckload of waste. There are two questions. Should I accept this or not? Is this correct? Why? I can denounce also. I can say, well, I will not accept your waste. Why? On what basis? Very good. Got it? Tomorrow this material is going to be a part of my landfill. And if you have not synthesized it earlier, the chances are what may happen? Times of India news tomorrow. Why? You never know from where this material came. What is the chemistry of this material? Suppose if I dump it over there, the temperatures are very high. This might be highly organic matter laden material. Hydrocarbons contaminated. Somebody has sent from somewhere. Clear? It might be having some explosive into it. This happens in city premises. I hope now you are realizing waste management is also not a very simple task. So, the waste management units at their checkposts and the entry point have these type of facilities. Why? They want to detect by sampling what is the composition of the waste which is coming in, whether it should be accepted or not. Is becoming a major issue. Why? So many types of industries are there. They are producing waste. What a landfill is supposed to do? Take care of all its possible customers. Did you realize? The point of descent has already started. Now, you are sending something which I am saying I will not accept, and you go and dump it somewhere. Where? Where should I dump it? Are you realizing the implication? What is the implication? Who should intervene now? Then why don't you stop this industry? Now, if you stop this industry, what are the consequences? Think. See, I have created a beautiful situation now. Hope you are realizing. The same is for export import also. You must have heard long back, there were few countries who were banning anything which was originating from certain countries. Why? At the same time, we were also banning the scrap which was coming out of different countries because of something. So, this something has to be quantified. So, I think now you are getting a feel of where this type of analysis can be required. So, fortunately, unfortunately, the chemical analysis is mostly being done by the guys who are mostly into consulting. Is this clear? Any questions? Why? Because there is an unresolved case. So, some of your batchmates are associated with this type of a situation. In cities like in mega cities, what is the major issue? You buy a plot of land. Got it? And then nobody discloses that what type of industrial process was going on here earlier. What is the implication of this? Why I am overemphasizing on this statement? But you have purchased the land. Now, what is that you are going to do with the land parcel? You are going to construct something on the top of this. Clear? And in the process, you realized that the land which I have purchased, when you started digging the foundations and creating underground reservoirs or parking lot, you realize that all waste. So, this is the story of most of the data centers which are being done in the country. Hope it must be giving you some ideas that where the subject is becoming so important and why so much scope is there to work on these type of problems which one person cannot handle. Are you getting this point? So, most of the discarded lands which were no man's land earlier are becoming easily sellable and commercial hubs. Why? Because you think that you have saved on the price of the land. Got it? And the moment you started execution of a project, you realize that what should I do? Interesting case. So, in my career, I dealt with several of such situations. So, this is how you get contaminated yourself. All right. Okay, now let's move on. So, I hope that I have given you enough idea about, in today's world, why these type of studies are becoming important. Okay, this is the ICP unit, age old, where I started my career about 30 years back, and this is the most modern, atomic ICP which you have in the system, IITs. And sometimes we use atomic absorption spectrophotometry also, if you do not want very high resolutions. Okay, these tools are becoming very important for environmental geotechnologists. When you create disposal facilities, when you create agricultural lands, when you create any type of activity. He was talking about dredging, is it not, Manal? So, when you are dredging out the sediments, the big question is where to keep them. If these dredge sediments are heavily contaminated, what port should be doing? Millions of tons, where are you going to park them? And if you park them inside the port boundary, then how are you going to manage the port operations? Are you realizing? So, this is where many people like you are required to analyze the samples which are coming out of the dredging. What is the biggest problem this world, the contemporary society is going to face or is facing already? Any idea? Food scarcity and water scarcity. Now, water is linked with your lakes, reservoirs. Have you ever realized that these lakes and reservoirs have never been cleaned in their lifetime? So, what is happening? Their capacity of storage is decreasing, including our city, and population is increasing day by day. Got it? So, how are you going to match the requirement of the population regarding the food? That is a different subject altogether, but as far as storing water is concerned is our subject, and the reduction in the quantity of water because of sedimentation is a major concern. Now, the question is, if you want to clean it up, if you want to de-sediment, or what is known as, what do you call it, desilting. De-sedimentation is not the right word, desilting is the right word. If you want to desilt it, okay, very soon you will be seeing there is a water body very close to our campus which will be desilted. The question is, what are you going to do with the sediments? It is not geotechnical engineering, because you have been taught what the soils are, how do you classify them, how to compact them, how to make them load bearing, how to make them shear stress bearing, how to make them stable in a form of a cut, slope, God knows what, clear. The only component which gets added up is they are coming from water body, their constituents are different, their nutritional values are very high, and they might be having a lot of organic matter. Now, what to do with this is a big question, clear. So, these are the tools which are to be depended upon in today's world, and we utilize this equipment maximum as a civil engineer. Why? Because most of the theses which I guided were either municipal solid waste disposal, nuclear waste disposal, industrial waste disposal, and creating the barriers for them, agricultural land contamination, oil spillage, contaminant spillage, and so on. So, these became very useful tool for us. This is the FTIR, very small equipment, but gives you a lot of information, as I said, and this is the NMR spectrophotometer, and all these are located in the facility which we call as the SAFE at IIT Bombay. So, whenever you get time before you leave IIT Bombay, please visit and see how much investment has been done by Government of India, because these type of facilities do not exist anywhere. Most of the time, people who pass out from IITs, when they become industrialists, they visit and they are surprised to see, well, what they missed out when they were here. Because first of all, the charges are extremely high. Number two are, there is a big queue, because these facilities are overutilized by the contemporary society. You can realize all industries utilize these facilities. Fine. So, before that situation comes, please visit and see what is the real wealth of IIT Bombay in terms of the advanced analytical instrumentation. It's a very rare place, and fortunately you guys are here. As far as pH determination is concerned, I am sure you must have utilized this in your school also, school days. There is a pH meter. You take the sample, dissolve it in water, make an extract out of it, filter it through the Wattsman paper or a filter paper, and then measure the pH. Where we are using this concept of pH is very interesting. You must have realized during my discussions that I am talking about degradation of the organic matter which is present in the geomaterials. A beautiful example of deviation of geomaterial is, earlier people used to talk about soil, rocks and groundwater, but what we created as geomaterial is the waste, anthropogenic geomaterial. Because truly speaking, this has come from the earth. So, this anthropogenic geomaterial, if it happens to be of municipal waste type or even industrial waste type, in the due course of time, because of interaction of environment and chemicals, it is going to decay. And once the decay process starts, what's going to happen? The leachates which are going to come out will be having a different pH. Got it? Now, very intelligently this change in the pH can be utilized by the guys to digest the waste inside a bioreactor landfill also. So, you check out the theses which I have guided in the past on bioreactor landfills. So, what do? I showed you long back that in a landfill, if I recirculate the leachate, clear? I hope you can understand. There was an analogy given by one of the famous politicians in the country who used to say that recirculate the excreta to digest the food. It's the same logic. Hope you can make it out. Very famous personality. Okay. So, the idea is that if this leachate can be recirculated by augmenting its biological activity, after dinner you take some, what is the digestives, clear? So, in the leachate, if I add these microbial activity, what they are going to do? They are going to digest the waste faster. So, these concepts are utilized in real life in designing the bioreactor landfills, and fortunately in Bombay we have one bioreactor landfill. I do not know how many of you are really visited. So, before you leave IIT campus and Bombay, my suggestion is at least go and see the bioreactor landfill, because it's very rare commodity. It's not in every continent, number one, clear. Number two is, I think Bombay was second or third city in the world where bioreactor landfill has been created. Before this, it was existing only in US. China has now several. So, the whole idea is how fast I can decompose the waste. And when you are decomposing the waste, you have to add some digestives. And what are those digestives? They are basically manipulating the pH of the fluids which you are injecting into it. That is it. Fine. So, you can do several of these types of analysis. You can measure the pH, temperature, total dissolved solids. Total dissolved solids also indicate the amount of turbidity in a solution. So, clean water before the industrial operation started, but after that what people noticed that this water became turbid. Why? Because of you. So, now the code will serve you a notice through MOEFCC, through CPCB, through MPCB, through this, through that, correct? Environmental watchdogs. The question is, how are you going to run your business? So, today's world, most of these industries are, have you heard about some term? ZLD, zero liquid discharge. Most of the companies have also upgraded themselves to zero gaseous emissions. Clear? the municipal solid waste or the industrial waste should also not come out of the industrial premises. Then this becomes a zero discharge industry, which is what everybody is trying to do, including your campuses where you are staying. IIT Bombay is trying to become a green campus. What is the meaning of this? We don't want to send our waste outside. So there were many initiatives, you are a part of many of the initiatives where the sludge, the wastewater and the municipal waste which is being produced by us should be digested by us, should be taken care of by us, should be converted into a resource which can go for some market applications. This is the whole philosophy. Now you design the whole system. And at every stage of this process, what you have to do? You have to keep on checking its chemical attributes. Why? If pH is too extreme, bacteria will not grow. The digestion is taking place because of bacteria. Unless bacteria is there, the gas will not get produced. This gas you wanted to use as a fuel. So now I think you have understood the whole process. Design a system, monitor it. This is the world of sensing technologies. Use sensors which are buried inside the waste units, and then you get all the data online in real time. How the process is being shaping up. What is the kinetics of the process? What is kinetics? You must be studying in your mechanics courses, correct? Now this is the kinetics of a chemical process. So this waste, if I can convert the entire waste into methane, and if I can utilize this whole landfill as a big source of methane, I need not to do methane gas, what is that? I need not to touch that deposit, because landfills are in every locality, and if I can accelerate the process of decomposition of the municipal waste, I can produce enough methane gas for survival of the nearby areas. This is the green energy, green waste management, sustainable energy, and then if you are producing lot of energy, put it on the national grid. So you are contributing to the national growth also. Hope you are getting a lot of dimensions about this. Waste to energy comes under the category of this type of a sustainable energy concept. That means the waste is being converted into the energy directly, and this waste comes from the landfills, legacy waste. A lot of plastics is lying over there, rubber is lying over there, thermocol is lying over there, clothes are lying there, furniture is lying there, wood, fiber, coconut shells, this, that, God knows what, because they never segregated it. Fine? Good. The last two things which I have written, three things which I have written is electrical conductivity, because electrical conductivity also gives an idea about what is the type of ionic species which you are going to create in the leachates, in the wastewater, after treatment, before treatment and so on. And then the chemical oxygen demand, you must have done in your environmental engineering course COD and BOD. So how the sludges are going to get treated can be monitored with the help of COD BOD, which is a established subject. So we used all these parameters in monitoring the landfills, okay, because the leachate which comes out from the landfills might be having very high BOD and COD. What is the meaning of this? I can't dispose it anywhere. Got it? So imagine a landfill of the magnitude which we are having in mega cities these days. It will be millions of gallons of landfill leachate which is getting generated. Now the question is how to treat it, where to dump it, where to dispose it. As per the environmental guidelines, you cannot dispose it anywhere. It has to be zero discharge liquid facility, zero discharge gases facility. Effluent gases can be burnt, you can flare them, but leachates cannot be. So there was a time when a lot of research was being done on leachate augmentation, all right, including our group. It's a very interesting topic to research on how to augment the leachate and what to do with the leachates. Hope you are realizing the problems. Is this correct? Any questions? Yes.
So my question is that, let's say if a landfill gets a waste which has very high BOD, so then how they treat it?
Leachates, not the landfill, leachates.
Because the leachates have a high BOD, so how do they go ahead with the treatment? Because
So, number one thing is that you cannot discharge them in surface water streams. You cannot throw them or dispose them in ponds, lakes, oceans, nothing, which has been done long back by several nations. Now your question is what to do with it. A effluent which is having very high BOD and COD, what is that you are supposed to do? Decrease it. How? By doing some process, digestion. So, you must have studied in your environment engineering course that they have different types of digesters, sludge digesters. Okay? This is what is installed. Number two is you create big tanks. Can you afford this much of land in a city like Bombay, Delhi, mega cities? Still we have few ponds which are running in kilometers of length, half a kilometer of width and tens of meters of depth. Siltation will be a problem, capacity will be a problem. There is something known as retention time, which you must have studied in environmental engineering courses. Unless you retain the sludge for a certain time, you can't treat it. Now the question is how to reduce its BOD and COD. The obvious answer is bring water, dilute it. The question is from where you will bring water. Okay, so what should I do? Vaporize the entire leachate and crystallize all the contaminants which are present. Seems to be very good. What is required? Heating, energy. Do you have so much of energy? Then what should be done? I am not going to give you an answer. What I am trying to give you is more and more a complicated situation. Fine. So, two things are ruled out. Now, what should I do? Third one, alter the properties of these leachates by adding some chemicals, augmentation and recirculate it. This is a simple idea, because pumping cost is not going to be too much. This is what the whole philosophy is for BLF. Okay. Another thing is, if you really want to decrease the leachates which are getting generated, see, because leachates cannot be stopped from generation, because the more and more decomposition of waste will take place, the more leachates are going to get generated. Clear? So, what you should be doing is, what else you can do? It is a very recent idea which I do not want to disclose. Filtration you can do, yes, very good. You have prepared tea ever in your home? What happens? If you use a filter, what happens? Very good. So, you are retaining something and the filtrate is going out. Why I am giving this analogy? So, you are using a membrane and you are retaining all these waste species on the membrane. A time will come when membrane has lived its life. Then what will happen? You want to clean it by applying back pressure. So, where this contamination will go? Now, it is in the concentrated form. So, you have to devise something. So, remember, you have converted the primary source of contamination to the secondary source of contamination. Most of the membranes get clogged, they have their life. Now, the question is, where should I dump them? This is one of the solutions, but why I am adding on to this complication? Because you should realize that membranes also cannot be used for infinite time because their pores will get clogged. If not because of the inorganic activity, it will be because of the microbial activity, skim formation. Okay. In the beginning of the course, I used the word biosolids. What were the biosolids? Which are coming out of the sewage sludge. Clear? And I think you remember that I also posed a question that we are clueless what we should be doing with the biosolids. Got it? And then I asked you to refer one of the pictures from Australia, I suppose, where there are big stacks of biosolids which have been created to deal with this problem. Fortunately, they have land. Unfortunately, we do not have much of land. So, this is how the whole situation is. I have not given you any answer for your question. What I have done is, I have given you more of a situations which should be making you ready for dealing with these materials. Okay, yes please. Now, what is your question?
My question is that as we know that most of the landfills are not engineered, so how are we gonna collect the leachates? Because like with rain, they will just seep into the water table.
Very good question. I wish that you should have given me an answer also. These are not landfills, by the way, these are dump yards. And that is one of the reasons why people want to get rid of these dump yards legacy waste, because there is no way by which you can stop leachate migration into the subsurface. There is no way. People have tried several schemes of barriers which we discussed in the class, you remember, by inserting sheet piles and confining the whole area, or by making slurry trenches. But please remember, as a geotechnical engineer, you have rights to question two things. How will you access the site? Because these sites were the marshy lands in most of the cases. Clear? You can't access these sites. Number two is, if you can't access the site, how will you install sheet piles and how will you do a slurry trench? Got it? Another big problem. So, unfortunately, the situation is this. The third possibility is, the technique which we are trying to profess is rehabilitation of the dump yards. Go on the top of the landfills or the so called landfills, dump yards, create leachate collection galleries. Let me drill out. Clear? Now, what you have done? You have drilled a well. So, what will happen? Whatever leachate will get generated will flow inside these leachate collection wells. Clear? And then you can apply suction also. So, apply suction. What is going to happen? Now, you are taking out all the leachates from the dump yards. This is the technique which can be done at most of the landfills. Your ignorance and not acting at the right time is going to cause problems to the entire society, because this is going to become a part of the surface water or the groundwater which people are drinking. So, I am happy that you are asking these questions. It shows that you are quite matured enough to become an environmental geotechnologist. So, now you have to exercise your mind to come out with a solution. No DNCing is going to give you an answer. Why? Why? Sorry? No. Second one. Answers are there. I gave you an answer just now. I said do it and show it happening. It's a big business. Similarly, collect the landfill gases also by drilling what do you call them as gas vents, correct? So, retrofitting of the landfills you have to do. It's a big business. Do it. Fine. Just a minute. The third thing is uncertainty, because after investing so much of money in creating these leachate collection wells and the gas vents, who knows, that you might not get gas at all from there. Then what will happen? Why? Why? Exercise your mind a bit. This is how the problems are solved. Why? It's a dump yard. So gas is leaking from everywhere. Had it been a closed balloon, you could have punctured somewhere and you could have collected gas and liquid somewhere, correct? That is the major problem. So even if you apply suction, you should have negated me when I said apply suction by doing these wells. The zone of influence of the suction is going to be almost zero. Why? Because everything is connected to the atmosphere. Got it? So now you have to take cases and evolve a strategy. That's the reason I told you that no de-ensing is going to give you an answer for this. Why? With all due respect, as he rightly said, nobody knows what this patient is going to behave like. Yes, now please ask your question. Yes, if you are unlucky, two things will happen. The leachate might get pulled up, and if the pressure is too high, it's just like your petroleum well, everything may ooze out, which I have seen happening. Particularly if gases are there inside, correct? The whole thing may come out like a fountain. Number two, methane may come out. Methane is flammable, very risky. Third thing is the whole system may collapse where you are standing. It's a risky proposition. Got it? So what you are going to do tonight? Write 200 words and then create a policy paper out of it and read more about what's happening in this direction. Don't think that this is just a gossip in the classroom. Truly speaking, we require solutions. And I think central government will be very happy, state government will be very happy if you can give solutions. How to proceed further. Otherwise, every time rains will come, water will seep through, degradation will keep on happening, leaches will keep coming out, you have to live with it. Go to any landfill site, you will see all these brownish, blackish, reddish water keeps flowing into and becomes a part of the water bodies. Who is getting affected? Everybody. Fine? Is this okay? Any other question? So what I have done today, I have tried to create a lot of questions for you. And that's why I say that chemical characterization is the key to profess environmental geotechnics. What you require is a beautiful laboratory on wheel, portable, which can be taken to the site. And there are several devices like CPT, cone penetration you must have studied. There is something known as environmental cone penetration test. That means you want to find out the resistance offered by the deposit and you want to sample also from there. Two things, gases and pore fluids. Pore fluids include gases also. So I know the complete profile of body profile of the landfill. What type of gases, what type of fluids, what type of liquids are present, what is the state of the decomposition of the waste, and how long we have to wait before we start biomining. Got it? This is the whole answer. Most of us are trying to do this work. So there are several landfills which we have taken. During COVID time particularly, we took a lot of samples out of these landfills. I think I had given you some information in the previous lectures and analyzed the state of the decomposition of the waste. Now, if the waste has not decomposed completely, you can't touch it. You have to live with it. So, land is locked for so many years. If you are an administrator, tomorrow if you become an administrator, how are you going to manage this situation? Imagine. Big question. Fine? Okay, let's move on unless you have anything else to discuss. Yes, please. I am sorry I cannot give you answer in terms of the dollars or rupees, but my job is to give you a lot of parallel ideas. Before you start doing this work, I will ask you for a feasibility report and how are you going to execute this project. Got it? Number 2 is I am going to ask you what is that you are going to do with the material which you are going to excavate. Third question is who are the buyers? Where are you going to use it? So, we have taken a lot of baby steps here. I think you must be realizing, all my PhD scholars, when they were presenting their research topics, I am sure you did not realize at that time what is that we are trying to do. We are trying to take baby steps, strides, to show in what way this bio-mined material can be utilized and create a big business out of it. Because unless this path is fathomed, the biomining process will not be initiated. Does this answer your question? So, your project cost is not only the cost of lifting from here and keeping it somewhere. First of all, identify where you are going to keep this landfill. Where is the place? At what cost? Start surfing on internet and try to question these things. What has happened in the past and how we have learnt these issues. I think you will get some information. Is this okay? Again, most of it falls in the category of the policy issues. How many things are there which are unknown? So, now create a big business model and start working in this. Fine? Good. So, just for the academic interest, let me bring you back to the classroom. Look at this table where I have shown you the cation exchange capacities of different geomaterials. So, my intention is just to show you, the units of cation exchange capacities are in milli equivalents per 100 grams. There is a IS code also on that. So, different geomaterials, when you obtain their cation exchange capacity, you will realize that the pure quartz shows you very small cation exchange capacity as compared to the chalk. Chalk is nothing but high calcium oxide, correct? Very high cation exchange capacity. So, this is one of the ways to characterize the material and to find out its chemical potential. Now, some time back you were asking a question that the leachate which is getting produced, how to neutralize it, and I said I do not have any answer. Truly speaking, there are several answers. Clear? One of the answers is, how are you taking care of the acid mine drainage? Read more on it. Acid mine drainage, AMD. How people have taken care of acid mine drainage which is coming out of the coal mines, and what happened when they could not take care of AMD. What were the instructions given by the judiciary, correct, and what happened ultimately? If I ask you to shut down your coal mines, what will be the impact of this on the society? How many people became jobless? How are you going to rehabilitate them? Number 2, already you are a energy deficient nation. How are you going to meet the requirement of the energy? Clear? Number 3, who knows, you might be exporting your coal also. So, that foreign exchange will stop. But the biggest question is, your mine is contaminating the whole geo environment, and hence I am asking you to shut it down. Got it? So, the way you were taking care of acid mine drainage, which was having the leachate of 3.4, 3.5, complete northeast, check out on net why most of these mines were supposed to become defunct, because wherever you have coal of high sulfur content, when it is going to be excavated, left forever to the atmosphere, the rains will come, the sulfur will get oxidized, in water presence it will become sulfuric acid, and that becomes a part of the rivers. Read this situation where it has happened in northeast and what was the action taken. Got it? So, if something is highly acidic, long back we were discussing about industrial byproducts, that some of them are highly basic also. Now, what you have to do? You have to create, I talked about permeable reactive barriers also in the class, PRBs. So, what you have to do? You have to channelize all this and pass through the filters which are made up of industrial byproducts of very high pH, red mud, gypsum and so on. This is one of the answers to your questions. Fine, good. Now, I have been talking about microbiological properties of the geomaterials quite a lot. Okay? So, we could not do much work, but though we have realized that its importance is too much because it requires a dedicated facility. So, what we have done is we did some work on this, and whenever you get time, you try to read this paper which has been written by students on what is the importance of bio-geo interface, a geomaterial coming in contact with the microbial activity, how this material would behave. This is another example of how to treat the leachates which are coming out of landfill. If I can use bacteria, and if this bacteria can survive in extreme pH conditions, I can mix the materials or dose the leachates with bacteria laden grains of geomaterials which will act as a seed to purify it, to bring down its COD and BOD. This is another intelligent way of doing it. So, you can use chemicals to lower down COD, BOD, which is what is done, or evaporate it, or dilute it, or freeze it, depending upon how big your pocket is. Got it? Okay. So, this is what we try to do, and just to give you an idea about how this bacteria grows on the substrate, and this substrate could be a grain of the soil. You can see here these are spores, and these spores are resting on the grains of the soil. These type of grains are welcome in the purification of fluids. Why? Because these grains enhance the cation exchange capacity because of the bacterial activity. This is how the spores look like. This is another interesting way of how microbial consortia looks like. And of course, this one, this is all a part of my consulting project which I have been doing some time back, where I started that the failure of the structure has not happened because of the geotechnical engineering oversee or overlook. It has happened because of these notorious entities which are sitting in the soil and making soil hyperactive and decay over a period of time, particularly in the organic matter. The biggest problem in dealing with the organic matter, concentrated soils is their decay over a period of time, particularly once you cut them, because organic matter decays. So, I picked up from here, and then we did some studies how MICP occurs, microbially induced calcite precipitation, and several applications are there. People have now realized that why MICP should not be done, because it is very expensive and not very interesting way to get a solution to the problem. We were discussing long back about in sedimentary deposits where you are doing mining, if you have to support extra deep cuts, can MICP be done? Theoretically yes, but nobody has executed it in field. This is also a question. So, I will just give you a quick idea about how pore solution sampling is done. Okay, we have talked about a lot today in the class, and there are several applications. Pore solution is identical to the blood sampling. If you want to understand how soil water contaminant interaction is taking place, you can do pore sampling. Then to predict the contaminant transport, pore sampling can be done from the source to the sink. You can have an array of samplers and you can take the samples and then you can analyze them by using ICP, GCMS and so on. Design of containment and barrier system, whether these systems are working all right or not. Then quantification and concentration of the waste disposal sites, whether the concentration and quantity which is coming out, you are talking about the leachate, is within the limits or not. How to attenuate the characteristics of the soils, so that the contaminants passing through the soil will not be released easily, attenuation. Pollutants in the groundwater, then prediction of the loss of nutrients, this is becoming a major issue for agricultural lands. How to preserve their fertility, nutrients should not migrate. And then detection of the microbial activity in the soils. And the last thing which is also gaining a lot of importance nowadays is the codes or the softwares which have been developed by the industries, how to validate them. So, a group of people is required who can give feedback from the field data to these analytical guys, so that they can upgrade their predictive models, which is also very important. It is a big requirement of the society and the profession. So, little bit on the sampling techniques. There are two types of sampling, one is done in the field, another one is done in the laboratory samples. We call them as the lysimeters. Lysi is the seepage, meter is one which measures the seepage. So, there are, depending upon the soil type, whether the soil is saturated, unsaturated, you can use tension lysimeters when the soil is unsaturated, and then when the soil is saturated it is zero tension lysimeters. There are salinity sensors which are available in the market, which gives you an idea about how much the soil is contaminated. And then there are few techniques by which you can see how much absorption of a chemical might take place on the soil mass. So, that type of techniques are there. In laboratory you can take out the sample, you can centrifuge it, and then you can see how much pore solution can be extracted. The concrete technologists also do a lot of pore sampling, because they want to study the kinetics of formation of gel in the concrete matrix. Then there are pressure membrane extractors. You bring the sample of the soil from the field and keep inside a pressure membrane extractor. I will show you. Apply pressure and then the pore solution filters out, just like squeezing juice out of the fruits, all right, something like that. So, these are the techniques which have been utilized by people, and particularly our laboratory, to see or to take out the pore solution, and once the pore solution has been taken out, you have mastered the state of the material. How does it look like? This is how it looks like. Inside the soil mass you bury a pervious fill. If you remember basic soil mechanics, there we have created heterogeneous dam sections by putting filter layers. It is something like that only. So, you dig out the soil, include a pervious fill and percolate the water and see how much time it takes for water to reach into this pervious fill and what gets washed away from this soil mass. So, you can connect it to the collection unit, and from there you can analyze the sample by using ICP or all. So, this is a simple technique, but I am sure you must have realized there are several limitations. You are disturbing the soil mass. There is another lysimeter like this which is designed for the similar purpose. There are limitations. In short, the basic philosophy is the question we have been discussing since beginning of this course is, if I have a waste entity, today also we have discussed about these membranes, after filtration they are becoming secondary, tertiary source of contamination, how to bury them in the ground and whether it is safe or not. So, this is the soil mass in which I want to bury the contamination unit, and then I want to do some accelerated tests to see if rainfall happens or rainfall occurs, what is the chance of leachate formation and what is the extent of contamination which it might create to the geo environment. So, these type of analysis can be done if you join any industry which is a process industry. There these type of studies have to be shown to satisfy the agencies which are going to renew your license, including the nuclear industry, correct. So, this type of nuclear waste disposal facilities, wherever you have, we created this type of a lysimeter long back to study that whatever nuclear waste comes out, whether the intensity of the radionuclides which are going to migrate in the geo environment are within the permissible limits or not. So, this type of designs can be done. This is a interesting equipment which is known as a tension lysimeter. This is just like your syringe through which you suck out the blood from the human body. This whole portion is buried inside the ground. This is a porous cap which is known as a cup, and then this whole system remains inside the soil, and then you apply vacuum to collect the sample. So, this is the lysimeter which is normally used when the soil mass is very dry. The earlier ones which I showed you are used for the systems when the soils are wet. Just to show you how this instrumentation was done at a waste disposal site, we created a confined volume and we did the moisture profiling from top to bottom. These are the plastic tubes which have been embedded in the soil mass, and then there is something known as TDR, time domain refractometry, which will give you the volumetric moisture of the soil mass. This is how the arrangement looks like. It is a ring, and this ring is tamped in the soil mass to create a control volume, and then you drill out two access tubes through which the moisture content can be measured or the TDR values can be measured, and these S1, S2, S3, S4 are the suction samplers. So, you insert them in the soil mass, take out the pore solution, and this was spiked with cesium, cobalt and tritium. This is the experiment which we did at a radioactive waste disposal site. This is how the arrangement looks like. This is how the sampling is being done, and based on this you can create mathematical models to show how contaminant migrates in the soil mass. It requires a lot of patience and a lot of efforts to do these type of experiments. We were doing these experiments at one of the sites, and unfortunately 26th July deluge occurred. We lost the entire experiment, by the way. It was submerged. So, here you can see how the doping is being done with the strontium and chromium to see how chromium and strontium will percolate inside the ground. And we use tritium also. Tritium is a very stable compound. Tritium is normally used for finding out the hydraulic conductivity of the subsurface. So, these type of results you are going to get, where as a function of depth how the moisture content is varying, volumetric moisture content is measured by using time domain refractometry TDR probes. And then by some mathematical jugglery which is published in this paper, you can get a feel of how in situ hydraulic conductivity can be observed. So, these experiments we did to simulate the process which occurs for almost 500 days, like cobalt kinetics, cesium kinetics and so on. Fine. I am not going into the details of all this analysis. Those of you who are interested can read the paper, and this gives you an idea about how much work civil engineers are doing in the field of waste disposal, which is nuclear waste. This is a typical pressure membrane extractor which I was talking about. So, you have a compressor unit, retainer unit of the compressed air. This system is the pressure membrane extractor, like a pressure cooker. And if you zoom it, this is how it looks like. It is a container where you can keep the soil samples in the dish, and then there is a filter at the bottom. You pressurize the whole system, and then the pore solution can come out, and this pore solution is collected into the bottles, and these bottles, which are known as vials, can be sent to the analytical chemistry lab. Fine. So, this must have given you an idea about how much is being done in the field of environmental geotechnology. My whole intention of showing you all this is that fortunately I, along with my students, could bring this subject from almost zero to somewhere, but a lot needs to be done from taking it forward from this point onwards. So, consulting was not in our agenda at that time, 20 years back, but the problem identification we could do, and the basic instrumentation we could do. And what we are realizing in today's world is, in this mad race of industrialization and infrastructure development, unless you practice these type of concepts, it is very difficult for us to proceed further. There is a lot of awareness in the society, and that awareness is also causing a lot of impediments in doing the work. So, truly speaking, the need of the hour is the guys who can isolate all trash from the facts, so that the projects can proceed further. I will stop here. Chemical characterization. I hope it must have given you an idea about the domain, which has to be explored a lot by civil engineers, geotechnical engineers, in collaboration with analytical chemists, and then come out with the basic models so that the industry gets benefited. Thank you very much.